Like so many others, I've been watching Suits. It's a drama about a group of people who work in a law firm, and one of the main characters, her name is Donna. Donna is the infallible legal assistant. She never makes mistakes. So Donna would never bill the wrong client for work because she transposed the client matter number. But Donna's got a trick up her sleeve. You see, client matter numbers are composite keys. The first half represents a client number with 6 digits, and the matter number only has 5. So if Donna was going to go make a copy, she would type in the client matter number. And if she were to transpose the two, the machine would beep better because it wouldn't validate that composite key. So I want you to be like Donna, an infallible software developer that uses strongly typed IDs. So why should we use strongly typed IDs? Well, suppose we have a function that takes in 2 integers, maybe a customer ID and an order ID. If we call that function, the compiler can check to make sure that the values we're passing in are both integers, but it can't check to see if they've been transposed. So what if we had a type that represented the customer ID and a type that represented the order ID? Then the compiler could tell us if they were transposed. And that's what strongly typed IDs do. They provide type safety for identifiers. So here's an example of what a strongly typed ID looks like for a customer. Now, I'm following Andrew Locke's implementation guidance. He has a great series of articles about how to use strongly typed IDs, and I'll provide a link in the description. Now, since I only really need a little bit of gingerbread around an integer that represents the customer, the type can be implemented as a read-only struct. So I can implement iComparable and iEquitable, and that'll just make the type a little bit easier to work with. So the problem with using strongly typed IDs with Dapper is that Dapper doesn't know how to map a SQL integer to your strongly typed ID. You see, there's a class called SQL Mapper. It's a static class that manages a dictionary of type mappings. And so to make this work, we're going to have to define a class that will perform that mapping from an int to a strongly typed ID. To define that mapping, we can create a class that inherits from SQLMapper.typeHandler. And there's 2 functions we need to override. The parse function takes in an object that can be cast to an appropriate type. And in our case, that's an integer. It could be a GUID in yours or whatever you're choosing to use. But that's passed into the constructor for the strongly typed identifier. And this function is used when converting the data from SQL to the values used in your domain entities. The second function is setValue, and it's used to assign the value of your strongly typed ID identifier to a SQL parameter, and that's used when you do inserts and updates that are made to the database. Once we've got that type handler, now we need to go ahead and add it to our repository. The SQL Mapper class has a static method on it to add custom handlers. So in the constructor of my repository, I'm just adding the handler for my customer ID. Now, if you've got a class where you register all of your repositories in dependency injection, maybe that's a good place to go ahead and register all these type handlers that you need for Dapper because they are static methods. You only have to do it once. Once it's done, then you can go ahead and execute your Dapper queries, and that value will be mapped to the strongly typed ID. So I hope this gives you some insight into how Dapper maps types and how you can implement strongly typed IDs in your Dapper repositories. Thanks for listening.